Okay, we are getting things set up really quick, guys. Just going through some live stream checks, making sure the audio is working. Okay, we are getting things set up really quick, guys. Just going through some live stream checks, making sure the audio is working. All right, cool. It looks like it's working. So, this video is actually something I've been meaning to make for a while now, but my life currently has been super hectic, so I haven't really gotten around to making it. And I wanted to make it a proper video, but I'm not sure I'm going to be able to have the time to do that at this current point in my life. But I did at least want to make a quick live stream about some things that I have to talk about involving the AnkerMake M5, particularly if this is going to be your first printer, which based on the comments that I've gotten on my last video that I did kind of comparing my custom Ender 3 to what we know about the M5, it seems like a lot of people are getting this printer for a particular reason that I don't think Anker ever marketed it as. And that's the people who are looking at this printer thinking it is something that is just going to work, as in it'll just work. And that's a bit of a concerning thing. I have many dozens of thousands of hours printing on various printers, and there are some things that if this is going to be your first printer, I think you should probably know. So what I'm talking about in particular, if I'm going to read some of the comments from my previous video, is, and I'm not going to quote or say who specifically said the comments. I don't want to like call them out or nothing. That's not what I'm getting at. And before I go any further, let me just state I'm not knocking this printer. I actually think the AnkerMake is going to be a perfectly fine printer. It's shaping up to be a decent product, but when I see comments that are like, I think the point of the AnkerMake is that it's a finished product that will give peace of mind. Nowadays, most available 3D printers are more like a never-ending DIY project than a consumer product. Other comments say, my feelings exactly. Anker feels like the first consumer-oriented thing that is simple to set up and go. Future will show if that's actually the case, and some people like to tinker and see that as a bigger part of the 3D printing journey. But for those who want to buy a printer, but one that prints in 3D, the Anker feels more geared towards that market segment. There's more comments like that, and okay, what I want to address is that when you first set up and go, it probably will work pretty decently. My concern is the same concern I have with literally every 3D printer, and that's there's no such thing as a 3D printer that is maintenance free. Maintenance is a routine part of keeping your 3D printer working. And if you don't do it, you're going to run into problems. And the Anker is not a printer that is going to be maintenance free. It will need to have some sort of work done on it at some point. And in this video, I want to go over the few things that if you've never 3D printed before, you need to be aware of. So that way you have, I just want to keep expectations realistic. That's really all this video is about. So let's talk about the design. So we're going to be going back to this build surface, this hot end in a minute. But I want to go over the parts that we can see on the listing here. So when you're using a 3D printer, especially when you're printing at high speeds, parts do wear out. And the faster you print, the more stress you're putting on the various parts in the printer. One of the things that will eventually wear out are the belts. So if you can look right here in this little video, this is the Y-axis build plate that moves back and forth, and it's powered by this stepper motor with the two shafts coming out connected to two belts. Now, it's actually a really good idea that they're using two belts in this application. For this type of printer, the way the Y-axis moves, having two belts is going to be far better than the single belt that I have on something like my Ender 3 Pro. But what they don't say is whether this belt is fiberglass reinforced or not. fiberglass reinforced belts last a lot longer and they don't stretch. So as you look, think of like a rubber band. When you move something in one direction and you suddenly stop, the rubber band's going to start to stretch a little bit. Now, the fact that they're using two of these is going to minimize that stretchiness, but over time, the belt is just naturally going to stretch. And without a tensioning mechanism, there's not much you can really do to compensate for when the belt starts to stretch. And based on what I'm seeing, I don't actually see a tensioning mechanism. But more importantly than that, when the belts do stretch to a point, they are no longer reliable and they'll need to be replaced. And based on what we can see and the videos that are available, if you look at, I think it was Short Circuit or some of the videos from Linus Tech Tips. Hold on, we actually just passed it up. This video right here, they actually do take the bottom build surface of the printer off, so you can see underneath it. And that's actually a great thing because we need to know what's going on underneath everything in order to do that maintenance. Now, when the belts eventually do wear out and need to be replaced, how easy is it going to be to do that? On a printer like this, we're having a situation where you're going to have to dig relatively deep underneath the printer to access a relatively basic component. It's probably not going to be that difficult, but you're still going to have to remove more components than you typically would than with a printer that's just like an extruded frame. And I keep going back to the Ender 3 just because most people are familiar with an Ender 3. The parts are very exposed on an Ender 3. So it's kind of obvious when something goes wrong. Now, when these go wrong, or start to go bad, I should say, because eventually they will, it might not be as easy to diagnose because I don't know how easy it's going to be to really look at everything in detail. That being said, you'll start to notice some sort of y-axis issues, and then it should give you a tip to check the y-axis belts. It's just not going to be as easy to diagnose just visually anyway. So speaking of things to diagnose, the hot end is another thing I want to talk about. Sorry, gotta take a sip of my drink every once in a while. So the hot end is a direct drive system, and that has pros and cons. The direct drive systems are great for any sort of print that has a lot of retractions. Direct drives are much more accurate with their retractions, and they don't need to have nearly as long of a retraction as something like a Bowden tube system. The downside is that when something clogs in the hot end of a direct drive system, it is a much more tightly integrated component. So you'll have to take that into consideration depending on how bad the clog is. And when I say clog, I mean eventually every hot end will clog, including this one. And let me talk about why that is. So this hot end is, as far as I can tell, not derived specifically from something like a Mark 8. It's kind of doing its own thing. It's nothing particularly special. It should be relatively simple and similar to most standard hot ends, even if it is all metal. But what I am seeing here is there's no real mention as to whether or not the nozzle is anything other than just brass. Now, if it's something like a hardened metal, it'll probably last longer. Well, it will last longer than brass. But let's assume for the moment right now that it is a brass nozzle. Well, brass eventually wears out. The filament going through the nozzle will create the bore at the bottom of the nozzle where the filament comes out to widen over time. And eventually, the 0.4 millimeter diameter hole in the nozzle that the filament comes out to will get bigger and bigger and bigger over time. That's a normal wearing part. That's expected. So when that happens, you'll have to replace your nozzle. Now, one thing that could be a problem, especially for those who are new to 3D printing, is the procedure for replacing a nozzle. And I'm going to give you my own experience, my own troubles when I was new with 3D printing and the things that I learned the hard way. So when you replace a nozzle, you have to have the hot end hot, and that's because you have to account for something called thermal expansion. Now, when you're tightening down the nozzle into the heater block, you have to maintain a specific torque, usually no more than 3 Newton meters. When you're doing this by hand, it's kind of hard to tell when everything is the proper torque, especially when it's hot and you can't really hold the components properly. You're usually using a tool so that your hand is not touching the heater block. You don't want to burn yourself. That thing is literally twice the point of boiling. And the problem with it is, from what I can gather, that heater block is aluminum. Now, the thing about aluminum, especially compared to something like copper in this instance, is that the metal is pretty soft. So when you screw the nozzle into the aluminum, there is a real risk that you can start to strip the threads of the heater block. And when the threads are even slightly stripped, what ends up happening is you'll never be able to seat the nozzle directly up against the heat break properly. So right in between the heat break and the nozzle will be a tiny gap where filament will ooze and build up and eventually clog, meaning you'll have to replace the heater block as well as the nozzle. So what I want to get at is, if it's aluminum, I guarantee those who are getting this as their first printer will make the mistake of over-torquing the nozzle and thus stripping the threads on the heater block. That's something that I did when I was first getting into 3D printing, and for the love of all that is good and holy, I could not tell what was wrong. Because at first, I felt like everything was still kind of tight. And it's not something you can really gauge without a visual inspection of the threads on the heater block, which means you'll have to take the heater block off of the hot end in order to actually take a look at it. So that brings me to my next point is, let's say you just have a worn nozzle and you're just replacing the nozzle. You put the new nozzle on, maybe you over-torque that nozzle a tiny bit, and aluminum's a really soft metal, so now you're getting a clog and you got to kind of figure out why. Well, in order to get to the point where you can take everything off, you have to get past all of this right here. Now, this probably isn't going to be the biggest deal in the world, but this shroud that goes over the entire hot end has a few issues. It blocks your visual of a lot of things. Hold on a sec. So, in order to do any real maintenance on a hot end, which eventually all hot ends will need maintenance, you're going to have to disassemble a relatively chunky amount of plastic to even just get a visual of what's going on in the hot end. So let's say you do have an issue where you've got a clog and you need to unclog it. Well, you've got to take off a bunch of plastic and get everything out of the way. And as far as your first layers go, there is an auto bed leveling system on this. As far as I know, it's a strain gauge. But auto bed leveling systems are not always perfect. In fact, they're not even necessarily auto bed leveling. They're really just more of a warp bed compensation, because when you print on a flat surface, well, nothing's truly flat. The surface is actually going to be slightly kind of warped, and the bed leveler is really just taking a look at how flat your surface is and compensating for the warped areas on your bed. That's really what a bed leveler is actually doing. So once in a while, that first layer might not go down quite so good. And I'm assuming there's probably a way to adjust the baby stepping, is what we usually refer to it as, so that you can get a perfect first layer. That's something you'll have to learn to do. Everyone has to learn how to get a good first layer. But, you know, eventually everyone does have a slight issue with something like perhaps adhesion, or maybe the nozzle being slightly too high or slightly too low on the bed, and just slight adjustments are something that just about every printer is going to have to deal with. Which brings me to my next thing, is the bed surface. So this bed surface here is PEI, which, good. PEI is my favorite material for printing on. PEI itself is also, as far as I know, a kind of plastic. You can actually print PEI if you have a very high temp hot end. PEI is somewhere north of 400 degrees Celsius for certain mixtures of PEI to properly melt. So you should never actually damage this PEI surface so long as you're printing properly on it. Now it's a soft magnet plate, which is great. So that means when it's hot, it's nice and sticky, and when it's cold, the parts will just pop right off, which is great. But like any build surface, including PEI, you will need to clean it. Now you can clean it in a variety of ways. You could just use Dawn dish soap, which is a surfactant, so it'll soak up the oils and stuff into the soap, and then you wash it away. You could use rubbing alcohol as a solvent to dissolve whatever might be on the build surface, and then you can wipe that away and get it nice and clean. This is not a big deal. It's just something to be aware of. You will have to clean the build surface, and if you touch the build surface with your fingers, the oils from your fingers are going to get on the build surface. Just remember to try and not touch the center or anywhere where the parts are going to print on, if you can avoid it. And you should minimize the oils, but you will still need to clean. Typically, after every print, you would clean it with something like isopropyl alcohol. Something like 80% or higher is recommended. I personally like around 90%, and I find that when the bed surface is slightly warm, around like 50 degrees Celsius, the solvent works a little bit better. But that's particularly with my PEI surface. Not every PEI surface is exactly the same. I use Genuine Ultim 1000 PEI. This, I'm not entirely sure their mixture, but I'm assuming it's probably some sort of powder-coated PEI for durability, which is not a bad thing. PEI is great. If you ever print, PEI is the way to go, in my opinion. Now, this is the hot end that they've got down here. The AnkerMake all-metal hot end kit. Cooling block, heating block, nozzle. Heating rod, temperature sensor, silicone sleeve, cool. Let's talk about this really quick, because this block is kind of funky. I don't think I've ever seen that block before. It's kind of reminiscent of an E3D V5 block, but not quite. So this is speculation on my part. So don't quote me on this one, but I don't know if that block is proprietary in any way. So if you do something like strip the threads on the heat block when you're putting in the new nozzle, I don't know if you'll readily find, at the moment at least, any replacement heater blocks out there. I'm sure once the printer comes out, there will be plenty of third-party replacements for it, so that's probably not an issue. As far as the hot end itself goes, well, this is the whole hot end, I'm sorry, the heatsink. That's a new one to me. I've never personally seen it, but it looks like it's got a good amount to dissipate heat, which should be fine. And if you look at the nozzle, that looks like a brass nozzle. So if it is brass nozzles are very cheap to manufacture. So when they wear out, you just throw in a new one. But one thing to be aware of is that when they start to get worn out and the bore starts to get bigger and bigger, the prints are not going to be as finely detailed as they were before. That's just something to take into account. So when that does happen, be sure to have some extra nozzles on hand to swap them out with. And the last thing, or I think the last thing, that I really wanted to talk about in terms of maintenance is this. So the Z-axis rods, or the lead screws, there's two of them, and they're encased in these pillars. Now the reason why this is a bit concerning is because these pillars are kind of buried in this, well, the Z-axis rods are buried in these pillars. And the reason why I'm concerned about that is because eventually the Z-axis rod's lead screw nut, which is typically made of brass, a softer metal than the lead screw itself, will wear out. And when that happens, your prints will start to have some issues in regards to the Z-axis. Now, this is, again, a normal part of any printer, and you will need to eventually replace them. When that point comes, it's going to be a little more difficult to replace those components because they are buried within these pillars, which means there's going to be more to disassemble in order to get to those components. Again, something like an extruded frame printer, those parts are readily available to look at, and you can visually inspect and kind of just grab them on the back just by rotating the printer and see what the wear is like at any given time. With these, it's not going to be as obvious because they're kind of hidden away. There's an aesthetic appeal to this printer, and because of that, there's a lot of components that are kind of out of the view of just being able to look at it. So when eventually they wear, it's going to be a little more difficult to tell, and when it comes to the point where you will need to replace it, it's going to be a little more difficult to get to. Speaking of that, actually, now that I think about it, there's another part of this that's kind of funny. So if we look at the printer right here, we've actually got this Bowden tube going from the filament sensor, which is right here, going into the hot end. Now, this is a direct drive system. It doesn't need a Bowden tube, technically speaking. Now, this is really just there to give a better filament path to the hot end, so that way filament is going through a predetermined path, not getting in the way of anything. That being said, when I was watching the video from Linus Media Group on it, there were some issues getting this filament to come directly through and into the hot end properly without having to take the Bowden tube off. They did have to take the Bowden tube off right here at the hot end in order to feed the filament through the opening of the direct drive gears. So it's just kind of silly that there's reliance on a Bowden tube in a direct drive system. I have direct drives like got my E3D Chimera on one of the printers on my Ender 5 right now, and typically speaking, it's really not necessary in a direct drive, but it's just a little annoyance that you might find if you're trying to feed the filament through and you can't get it to go through. You're probably going to have to remove the Bowden tube from right here, which is usually just held in with a little collet of some sort, so it's not that big of a deal. Just be aware that if you're trying to poke it through and it's just not going through, take the Bowden tube off, feed it through, and then put the Bowden tube back in the locked position, and you'll be fine. Just silly little things like that. Let's see. But I think that's kind of the only real concerns that I had with this system. The AI system I have yet to actually see work on any of the videos. I've watched two videos, one from Linus Media Group and one from, actually, just for make sure I get this right. It was one of these. Anywho. I don't think I've actually seen a video yet of the AI system in action. It's probably a lot like Spaghetti Detective, if I had to guess. Spaghetti Detective is basically an AI system that keeps a look on your prints, and if it detects what it thinks to be spaghetti, which is when the print fails and then you're just kind of like extruding plastic into thin air, it'll stop the print, that sort of thing. Beyond that, there's really not much else to talk about. I'm sure it's going to be a fine printer. It looks like a well-made machine. The components are not going to be CNC machined. They are going to be cast, I believe, at least if I remember correctly from Linus Media Group. They were saying that, and yeah, I'm sure it's going to be pretty good. Oh, actually, there's one last thing, and that was pointed out to me. Unlike my printer, this printer is running on V-slot rollers. So let's talk about a V-slot roller really quick. So it's kind of going to be hard because we don't have many pictures from the back. But if you notice right here, that's a little wheel. Basically, there's wheels that roll across the extrusions right here on the x-axis. Those wheels have bearings inside of them, and you will need to lube those bearings once in a while. That's standard. We see these types of bearings and V-slot rollers on tons of printers. You just want to oil them once in a while. Sometimes dust will kind of stick to the bearings. You want to clean those a bit once in a while. And as far as the y-axis goes, I don't know exactly what that's running on because I haven't seen any pictures from underneath. If the y-axis is also on V-slot rollers, you will once again want to remember to lubricate those components. It's the same. It'll be the same kind of thing where there's bearings right here in the same way they'll be down here if it's a V-slot roller, and just make sure to keep them lubed up and you should be good to go. So beyond that, I think that is all the things that I wanted to talk about, and just make sure that you're all aware of those things if this is going to be your first 3D printer. It will not be a printer that is maintenance free. That sort of thing just doesn't exist. You want to make sure you're aware of the things that need to be taken care of, looked at, and make sure everything maintains a working order. Parts wear out. That's just part of 3D printers, really any sort of machine, really. And the more aware of those specific components you are, the better off you'll be in the long run, and you'll know what to look for. And hopefully there will be some good guides out there when the printer is available in terms of doing said maintenance. So that's all I wanted to talk about. Just wanted to make sure you guys were up to date on that, because like I was saying, I was getting some comments that were basically people want this as their first printer because they believe it's a printer that will just work. It'll probably work pretty well, but eventually every printer has a few issues that need to be taken care of. So I will stop gassing on because that is the gist of the video. Thanks for watching. If this is going to be your first printer, let me know. And in fact, when you get it, I would love to see your videos regarding this printer because it is an interesting design. And it's an interesting thing that, they're aiming for this speed. We'll see long term how well that works out. You're still going to need to slice your designs in order to work with this. The things that come with the printer are probably very, very well tuned, specific to that printer. Every printer has some pre-sliced files that come with it that'll work perfect out the gate. Once you start doing your own thing, it becomes a little bit more sketchy. But, we will see once the printer is released. I'm looking forward to people showing off their new printer, and we'll all see how it works out when it's fully available. So thanks for watching, guys. I will see y'all in the next video.